Okay, the characteristic function is defined as the expected value of e to the power j omega x. So we want to obtain a very important property of the characteristic function, that is the moment generating property. Using characteristic function, we can obtain the moments of different distribution functions. So how can we obtain this? It's pretty simple. If we differentiate the characteristic function, which is a function of omega, in terms of omega, we will see that from the basic definition of the characteristic function, if we differentiate this definition and exchange the order of differentiation integration, that is, take the differentiation sign inside and differentiate e to the power j omega x, it simply becomes jx e to the power j omega x into the PDF. So if we evaluate this value, that is the value we obtained here, if we evaluate this value for omega equal to 0, we will obtain jx fx, because e to the power j omega x by omega equal to 0 is simply 1. So this by definition is the expected value of x. So the characteristic function differentiated once with respect to omega gives jex. If we carry out a differentiation for the second time, that is, if we differentiate this function, that is the function we obtained after differentiating once, we will simply obtain j square x e to the power j omega x. That is, we will obtain j square x square e to the power j omega x if we differentiate the first derivative to obtain the second derivative. And we know that j square is given by -1. Okay, and again, if we evaluate the second derivative for omega equal to 0, this term will again become 1. So we will obtain x square PDF of x dx differentiated from integrated from -infinity to infinity and a minus sign in front. So this becomes minus expected value of x square, because obviously this is expected value of x square. So in general you can write, that is, if we differentiate, if we find the nth derivative of the characteristic function and evaluate it at omega equal to 0, we will obtain j to the power n into e to the power xn. So if by differentiating the characteristic function and evaluating at omega equal to 0, we can obtain the different moments of a probability distribution function or different types of random variables.